Welcome to ProjectPro code recipes. In this video, I'm going to show you how to use DBSCAN based clustering in Python. So this is the code snippet over here. I've copied this code and I pasted it in my Jupyter notebook. I'll explain to you the code way as well as run this for you. So let's get started. Now, this is in continuation with the previous video in which I explained uh, mean shift clustering. So you need, if you want to see that, you can first see that mean shift clustering, then you can see this DBSCAN clustering. As that video was getting too long, that's why I stopped it in the middle and I switched to a new video in DBSCAN for the DBSCAN. Now DBSCAN. So DBSCAN stands for density based spatial clustering of application with noise. So it is based on the phenomena so it takes into account the density distribution of your data set. So how does it work? As you as in the previous video I explained how does k means clustering work. So even if one point gets inside that RBF kernel, that RBF circle, uh, it the mean shifts. If the mean shifts, it considers that it is still in the same it is still in the same cluster and it doesn't changes the cluster. So basically there can be instances where the data is very sparsely distributed, but we know if there are clusters they are going to be very close to each other. But even if the data is sparsely distributed and I keep my bandwidth to be too huge, my steps are large. Even if one data point creeps in and and the mean changes, my my cluster is not going to change. Even if my cluster should change at that point. Now this is taken care by DBSCAN as it takes into account the density rather than the mean. So how does this work? You basically need to pass two functions. Sorry, the two hyperparameters, the distance and the minimum number of points. So and then the density is calculated. Now let me show you the figure and explain it to you. So you can see these are the densities and these are the two hyperparameters that I was talking about. First is epsilon, that is the distance, and then is the minimum point. So if I pass, so when I pass epsilon to be anything x, now a circle of radius x is drawn around the core point. So this is the core point. A circle of radius x is drawn. Now minimum samples. So all these are the minimum samples that when a circle is drawn, it is taken into account that this number of minimum samples are always present around that point, and this is how a cluster is formed. Now core point. So there are three things: core points, border point, and noise points. As I told you, it works much more better than it also works much more better than key means, as it also takes into account the noise point. So so these are the core points. So core points are basically the points when an circle of epsilon is of distance epsilon that you pass is drawn around that, there are at least this number of minimum points inside that circle. Now border points. So with a distance of epsilon, there is at least one data point uh, within that vicinity of within that vicinity of point. That point is known as border point. And for the noise point, the points that don't come under the noise point and the core point and the border point are known as noise points. So this is how DBSCAN clustering work. So how is that is advantageous as it is based on clustering. So let me take the example of previous thing. So in the previous video I just explained about uh, mean shift clustering. So I'm using the same graph. So you can see if I'm using a density function, the density over here is very low. But if I was using my k-means clustering, sorry, my k-means clustering or my mean shift clustering, if my RBF, if my the radial basis function is taking large step, it can shift from this point to this point by not taking into account these void region. But when I use DBSCAN and it encounters a region of low density, this density is basically decided by the distance and the minimum number of samples you pass. So you need to hyperparameter tune them. Then it stops clustering and it starts a new cluster from that point. So this is how this works. Now this was about understanding DBSCAN. Now let's go through the code, as this video is more focused on implementation of DBSCAN through code. So sklearn.clusters import DBSCAN, standard scalar, and import datasets. I'll be using iris dataset. So x iris.data, data is equal to pd.data frame x. So this is the correlation matrix, this heat map. I'll be visualizing this correlation matrix using this heat map. Now I'm standardizing my feature. So standard scalar DBSCAN. So I'm passing if is equal to 0.7 and minimum sample is equal to is equal to 8. Models clt.fit. Clusters I'm converting then this prediction of this model using into data frame. Then I will be using this data frame in order to draw the graph. So let me run this. As it is running, I'll show you something. So there are many hyperparameters that is taken by DBSCAN. You can check them out over here in the sklearn. You just need to write sklearn.dbscan. So this will pop up, and this is basically the documentation. So you can see EPS and minimum samples. The default is 0.5 and minimum sample is 5. And matrix is Minkowski. The default matrix. So matrix is basically the method of calculating the distance. So you can also go for Hemming distance. You can go for uh, Euclidean distance. Euclidean distance is the distance that we calculated in our basic coordinate geometry class when we were in standard 9th or standard 10. So you can change them and check that out. Now these are the clusters form. So you can play with these hyperparameters and you can check how your clusters are changing and you can perform a great search. This was all about codes in this video. Uh, for more code recipes like this, you can visit our website as well as our YouTube channel. You can also visit our website for much more industry relevant projects that are done by industry experts. If you like the video, please hit the like and subscribe button, and the URL for the code of this video is available in the description below. Thank you.